In this example, we want to examine the graphs of a couple of exponential functions. So let's look at this exponential function that's given in part A. Notice that the initial value of this exponential function, which is this coefficient in front of the power, is 3, and then the base of this exponential function is 2. So I've used the computer to make a graph of this exponential function. Notice it's a fairly simple graph, and that's characteristic of exponential functions. Because the base here is 2, and that's a number greater than 1, then notice that this function is going to be increasing always from left to right. And so that's true of all exponential functions that have bases greater than 1. The functions are always increasing from left to right. And another thing that's characteristic of the graph of exponential functions is that the y-intercept of the exponential function is going to be the same as the initial value for the exponential function. So notice the y-intercept of this graph here is 3, and that's the same as the initial value of the exponential function. Notice also that this curve doesn't have any turning points. It doesn't have any local maxima or local minima, and that's also true of exponential functions. They do not have turning points. They don't have local maxima or local minima. Moreover, although you might be a little bit misled here on the left, exponential functions do not have x-intercepts. So notice this curve, although it gets indefinitely close to the x-axis, on the left-hand side, it's not going to cross the x-axis. It does not have any x-intercepts. So exponential graphs of exponential functions with where the base is greater than 1, those curves roughly look like this curve. They may be steeper from left to right, or they may be less steep as you move from left to right. But you get this same basic shape for exponential functions where the base is greater than 1. Now, let's look at the graph of this second exponential function in part B. This also has now an initial value of 3. So the y-intercept of this graph is also going to be, the graph of this function is also going to be 3. But on the other hand, now the base in this example is 1/2, and that's a number that's less than 1. So exponential functions where the base is less than 1, their graphs are going to be decreasing from left to right always. So here's a graph of this function 3 times 1/2 to the x power that I've drawn here with the computer. And notice that the graph is decreasing from left to right as opposed to increasing left to right. And that's characteristic of exponential functions where the base is less than 1. Still, the y-intercept here is the same as the initial value. So we have a y-intercept here of 3. And no turning points, so no local maxima or no local minima on the graph, and no x-intercepts, although this curve is getting indefinitely close to the x-axis on the right because the graph is decreasing. It's still never going to touch the x-axis. There aren't any x-intercepts for this graph.